Good evening, students. In this session, I am going to demonstrate how to find inverse of matrices 2 by 2 and 3 by 3 using method of matrices. That is how the question is put in CBSE, using method of matrices. Students are supposed to use the formula A inverse is equal to 1 by determinant A times of adjoint A. So that is the formula. The determinant A happens to occur in denominator, 1 by determinant A. So definitely the inverse of a matrix doesn't exist if determinant A is 0. Determinant A becomes 0. Determinant A becomes 0 implies there is a special name for the matrix, then the matrix is called a singular matrix. Singular matrix. If determinant value is 0, the name given to matrix is singular matrix. In essence, to get the inverse matrix of A, it should be non-singular. Non-singular. So this is what we are going to. At the initial stages, we need anyway the formula requires value of determinant A. So once you discover the determinant, you will be in a position to ascertain whether the determinant is 0 or not. Thereby you will also ensure inverse exists or not. Let us go ahead. I have just kept a 2 by 2 matrix and a 3 by 3 matrix ready. These are nothing but questions given in exercise 4-5 of NCERT. Let us go ahead. Let me take the matrix as A, 2, 4 in column 1, minus 2 and 3 in column 2. Straight away, I am able to write the value of determinant, which is simply product of diagonal elements 2 into 3 minus of negative 2 into 4. So I can say it is 6 plus 8. The answer is 14 and it is not 0. So therefore, the inverse matrix exists. So inverse matrix exists is the fact which the students have to present. Thereafter, we can write the adjoint A before preparing the inverse formula. Adjoint A for a 2 by 2, you can skip the procedure of writing the cofactor and you can directly write the adjoint because there is a shorter method present. What is that? The diagonal elements 2 and 3 in this case, they have to be interchanged. The other elements, the sign needs to be reversed. So negative 2, I am writing positive 2 in its place. 4, I am writing negative 4 in its place. So this is the adjoint. And now we can write the inverse of A. That is A inverse. Produce the expression 1 by determinant A times of adjoint A. You are already aware of the answer for determinant A as 14. So let me put it as 1 by 14 and adjoint, that is 3, 2 in row 1 minus 4 and 2 in row 2. So that completes the presentation of inverse matrix. Once again, for verification, students need to spend probably half a minute or more so that you ensure that full score is available, because there could be some error can creep in anytime. Let us verify the product of A matrix and A inverse matrix. 1 by 14, you put it out, it's a scalar multiplying both matrices. So to verify, let me put it this way. 1 by 14 of Sorry, there is some, yeah, 1 by 14 of 2 minus 2, 4 and 3. The inverse matrix elements in place 3, 2, negative 4 and 2. All right, so let us produce the product. First row, first column, 2 3s are 6, minus 2 into minus 4 makes 8. Accumulated sum is 6 plus 8, giving you 14. And first row, second column gives 4 minus 4. Second row, first column gives 12 minus 12. Second row, second column makes 8 plus 3 times 2. So that makes 14. And outside there is already 1 by 14 present. So that gives the exact identity matrix 1001, which is of order 2. Identity matrix of order 2. So this entire verification process is not part of the solution, body of the solution. It is exclusively verified in rough column so that you are sure of the entire score. Well, let us move on to the other matrix. Let me now take that as A. So column 1 has 2, 4, negative 7. Column 2 has 1, minus 1 and 2. Third column 3, 0 and 1. Fine. We cannot skip to directly adjoint. Here there was a short method present. Here we need to evaluate determinant A. Let us do it. Let us ideally use the default method expansion by row 1. Okay. So row 1 has got 2 into its cofactor. Its cofactor is product of diagonal elements minus 1. And thereafter by default cofactor sign is negative. A12 into cofactor. Cofactor minus is returned. Now I am going to write minor 12. So it is 4 times 1 minus 0. So it is 4 only, and plus A13 times cofactor 13. Cofactor 13 is same as minor 13, which is 4 into 2, 8 minus 7. So 1 only. It is 8 minus of minus into minus, so minus 7. Right. We will proceed to the answer. It is negative 2, negative 4 plus 3. Answer minus 3. Anyhow, we are happy that the determinant is not a 0, hence non-singular. Because A happens to be non-singular, the inverse exists. Okay. So inverse of A exists. Well, now our intention is to produce a joint matrix, which is not possible unless you prepare all the cofactors. So cofactors in row 1 will in order write the A11. So when you write A11, write the minor 11, which is negative 1 only. A12, I told you by default there is a negative sign, and write then minor 12. Minor 12 is 4 into 1 only. So the answer is minus 4. We can proceed to A13. A13 is same as minor 13, which is 8 minus 7, 1. So that completes row 1. And for row 2, let us start writing A21 begins with negative sign. Then write minor 21. Minor 21 gives the 4 elements visible 1, 3, 2, 1. So it is 1 minus 6. So the answer is minus of minus 5, positive 5. A22, it is minor 22 only. So 2 times 1 minus of minus 21. So 2 minus of minus 21. So it is 2 plus 21. The answer is 23. Let us proceed to A23. By default, it begins with negative sign because 2 plus 3 is odd. 2, 3. So leaving row 2, column 3, I find 2, 1, minus 7, 2. So the determinant is 4 plus 7 makes minus 11, completing row 2. And proceed to row 3, element 3, 1. Element 3, 1. Okay, so minor 3, 1 only. 0 minus of minus 3, positive 3. A32 begins with negative sign. Minor 32. Minor 32 is 2, 3, 4, 0. So 2 times 0, 0 minus of 12. So positive 12. Let us complete 3, 3 here. Minor of 3, 3. That is 2, 1, 4 minus 1. So it is negative 2, negative 4. Negative 6 only. So let us now our intention is to produce adjoint matrix, which is not possible without combining cofactors, presenting a cofactor matrix. Cofactor matrix, let me give the name C. So cofactor matrix, we call it C. So C matrix is made of cofactors replacing the respective elements given in the matrix. So in place of 2, you replace A11, cofactor 11. Replace 1 with A12, negative 4, and A13. So just go on writing the cofactors in their relevant locations. A21, 5, A22, 23, and A23 negative 11, 31, 3 and 32. We have 12, and cofactor 33 is negative of 6. So that completes the cofactor. Cofactor matrix, once you arrive at this, you need to transpose. Present the transpose so that you will get adjoint matrix. Adjoint A is cofactor transpose. So therefore, we get the adjoint as, you can transpose, so minus 1, minus 4, 1. Row 1 in the form of column 1, 5, 23 and minus 11 as column 2, 3, 12 and minus 6 as column 3. Now we are ready to write the inverse of A. A inverse, write the expression 1 by determinant times determinant of A times adjoint A. We discovered determinant A, which is negative 3. So it is minus 1 by 3 of, again rewrite the adjoint, minus 1, 5, 3 in row 1, negative 4, 23, 12 in row 2, 1, minus 11, minus 6 in row 3. Well, so that completes, in effect, that completes the inverse procedure, and that can be given as the answer. Before students leave that as the answer, I always appreciate the students if you verify the result whether matrix A multiplied with inverse, whether you get the identity matrix, in this case I3. Let us multiply. You can multiply in any order, not necessarily A times A inverse. So, in rough column, let me write the A matrix by the side of the inverse matrix. So, 2, 4, negative 7 in column 1, 1, minus 1, 2 in column 2, 3, 0, 1 in column 3. Let us prepare to multiply. The scalar minus 1 by 3 is lying outside. We can go ahead. First row, first column. So, first row, first column, multiply the corresponding pairs. Minus 1 into 2, 5 into 4, 3 times negative 7. Let us go ahead. Minus 2, 20, minus 21. So, what are the numbers? Minus 2, minus 21 and positive 20. That gives, we know, minus 3. That gives you negative 3 in position 1, 1. Let us continue. First row, second column, find the products and accumulate the sum. Minus 1, 5 into minus 5, positive 6. So, minus 1, minus 5 plus 6 makes 0. First row, third column, minus 1 times 3, then 0 plus 3 makes 0. What about second row, column 1, minus 8, 23 times 4, that makes 92, and 12 into minus 7, minus 84. So, it is 92 minus 92, minus 84 minus 8 and positive 92 makes 0. And that's brilliant. Now, you can go ahead, call row 2, column 2. So, minus 4, minus 23, that makes minus 27. Minus 27 plus 12 2s are 24 gives minus 3. Minus 3. Then, second row, third column, negative 12, 0 and positive 12 makes 0. Third row, column 1, 2 minus of 44 plus 42. So, 42 and 2 is 44. With minus 44, the accumulated sum is 0. Third row, second column makes 1 plus 11, 12, minus 6 into 2, minus 12 makes 0. Let us complete third row, third column. 3 and 0 and minus 6 brings minus 3. Divide every element by minus 3 lying outside. You get 1 0 0, 0 1 0, 0 0 1. Is it not? Okay. Is it necessary to write it? We know it. So, that completes the process of finding inverse also, verifying also. So, thereby you are assured of the full score. So, students, I appreciate you try doing similar 3 by 3 matrices. Carefully evaluate cofactors, write the adjoint, and do not forget to verify. Thank you. The next session we will see how we can solve systems of linear equations. Thank you, students.